I want to take another look at those last two Pythagorean identities, but I want to do it from an algebraic standpoint and use a couple of the other identities that we saw, in particular the quotient identities. So I'm going to start with this one, sine squared a plus cosine squared a equals 1. And what I want to do now is I want to take this, I want to divide both sides by cosine squared a. So I'm going to divide this side by cosine squared a, and I'm going to divide this side by cosine squared a. Okay. Dividing is the same as multiplying, right? If you're dividing by 2, it's the same as multiplying by a half. So there's a distributive property that would take this and put it into both of those. So I've got sine squared a over cosine squared a plus cosine squared a over cosine squared a equals 1 over cosine squared a. Okay. Now, a couple of things here. One is the notation. Remember, this is the sine of a in parentheses squared. Likewise, this is the cosine of a in parentheses squared. So I can rewrite this as the sine of a divided by the cosine of a, that whole thing squared. I mean, how do you square a fraction? You square the numerator, you square the denominator. So we end up with that. Here, I've got the same number, top and bottom. Cosine squared a divided by cosine squared a. Well, goodness, that's equal to 1. And then likewise here, I'm going to rewrite this as 1 over the cosine of a, that whole fraction squared. Usually we go the other way. If I have a fraction, I square it. I'm going to square the numerator. Well, 1 squared is 1. And if I square the denominator, cosine of a, that whole thing squared is, and that's our notation for it, cosine squared a. Okay. Now, here we have a couple of identities. One, this is a quotient identity. Sine of a divided by cosine of a, that's equal to the tangent of a. There's a 1 right there. Here's a reciprocal identity. 1 divided by the cosine of a. Sorry, that shouldn't be a plus sign. That should be an equal sign. 1 divided by the cosine of a. That's the secant of a. And then, just to write the notation the way we usually do, tangent of a, that whole quantity squared, is also written as the tangent squared of a plus 1 equals the secant squared of a. And there you have that second Pythagorean identity. Now granted that I have the left-hand side written in the other order, but addition is commutative, so it doesn't matter if you say 1 plus tangent squared a or tangent squared a plus 1, they're equal to each other. Okay. So that's the second one, looked at in an algebraic process using a couple of identities that we had earlier. I want to do the third identity as well. We'll start again from sine squared a plus cosine squared a equals 1. And this time, rather than dividing by the cosine squared a, I'm going to divide both sides by sine squared a. And somewhere in the background, in another room, a phone is ringing. I don't know if you can hear it. But here we go. We divide both sides by sine squared a. Notice again that there's a distributive property here that'll allow that to be divided in. So this is sine squared a over sine squared a plus cosine squared a over sine squared a equals 1 over sine squared a. Let's see. Well, sine squared a over sine squared a is 1. Take any number and divide it by itself, it's 1. This thing I'm going to write like this. Whoops. On the top, I've got a cosine a. On the bottom, I've got a sine a. And I've got that whole fraction squared. Again, right? How do you square a fraction? You square the numerator, you square the denominator. And that's what that is. And then likewise here, this looks like 1 over sine of a, quantity squared. So on a button, what do we have? Oh yeah, this right here, there's a quotient identity. Cosine of a divided by the sine of a, that's cotangent of a. And that's squared. Inside the parentheses here, I've got 1 over the sine of A. Reciprocal identity tells us that that's the cosecant of A. And I have that squared. So just switching the notation here, this is 1 plus the cotangent squared of A equals the cosecant squared of A. Right? And there's that third Pythagorean identity looked at from a point of view of using algebra and trig to show that it's true. Okay.